Welcome to the version 1 demo for SleepMO. My name is Abiram, and I'm here to show you how this project really works in the most tangible and suitable format. This project, SleepMO, is really focused on providing sleep data and sleep recommendations for individuals based on the brain data of certain individuals as well. It focuses on computing the signal-to-noise ratio of brain data by computing it using a brain vision file. What that necessarily means is that it takes a certain file of data and we're computing a signal to noise ratio, which means that we're selecting a certain frequency in that brain data, taking the power of that signal and necessarily dividing it by the noise of the other bins, frequency bins across that. What this initially does is that this helps us to kind of find like a power value within, because the noise of other frequency bins is just the artifacts in the EEG, in the brain data, and that's compared to this certain frequency to select for, in this case 12 hertz. This helps in kind of calculating like a power value, and we use the signal to noise ratio and we compare this to a certain melatonin value. This is one of my key assumptions here that I will come into later in the video. We use this melatonin value as a way to provide recommendations by using some sort of prompts where we're checking to see if these values correspond to certain values, and based on that we generate certain prompts, because of course if you were to be at a certain value or a certain level in your melatonin, you might realize that maybe you might need to improve it. Maybe your pineal gland has to produce more melatonin to make you feel more sleepy, actually help you sleep better, right? As compared to someone else who might have a higher melatonin level at that point in time in day, they may not actually have to face as many recommendations. So in this case, the main idea is that it's going to take individual data and based on that kind of corresponding to brain data and use that as a way to provide recommendations. Now the key assumption to focus on is that there are actually no biomarkers for melatonin just yet. So the melatonin values that I have associated to the signal to noise ratio values are assumed values and are not accurate values. And so that's something I'll be working on in the next few days and weeks as I continue to fully fledge out this project and build it out so that it can actually be applicable to other people and actually help people sleep better. So my goal for this video is to show a certain demo of how the project actually works and how it provides prompts. So I'll be running here, starting up a server. Notice we get a server here for port 5001. And now we're here. This kind of field is actually the website that I'm trying to build out to actually help people use it. Right now, it is kind of in its early stages, but the beta testing part is that it uses Flask as a way to take the code and the values from the HTML form, which is right here, into the Python function. Say my name, 15, and I'm going to say 8 hours. And the subject number, session number is the key things we focus on, because based on these, you get a certain signal to noise ratio, and you're comparing that to melatonin values. So whatever you compute here, it gives you a certain signal to noise ratio, compare that to melatonin values, and you get certain prompts on how to sleep. One, so subject 2, and then their first session. I'm just going to say dash the Gmail email, and here I can either say specific or general based on if I type 1 or 2. So I'm going to type 1 and try to get specific recommendations. Submit. Just get a file open here that says my own personal sleep recommendations. Through computer melatonin levels, we hope that you do these things. And it might show that a tracking mechanism, it's not intended to show tracking, it's rather to show remarks on how a person is doing and if they are to be kind of following around with their sleep recommendations. And in the most general format, it gives you these based on the melatonin levels that I said was an assumption. And then we said, here's specific ways to conduct recommendations. For example, I put 3 different ones here, and they're not exactly what's mentioned here. It was just for the prompt engineering system to work. So blue light emissions, maybe one tip would be not to use screens for at least 13 to 15 minutes before you sleep. Caffeine, don't drink caffeine before 2 p.m. because of adenosine. Now it can mimic and actually make you stay up at night because of the half-life. Maybe sleep habits. Maybe to correlate back to blue light emissions, put your phone away and maybe look towards journaling or preparing your bag for the next day. So these tips are meant to be personalized just to help people feel a sense of self based on how it could be modeled based on other person's brain data. What I'm expecting is that these data is the data is representative of another person, and based on this, it's able to provide specific tips that actually help people have personalized recommendations to help them sleep better.